Hey, this is Jody with weldingtipsandtricks.com. Today we're talking about the differences between lift arc, scratch start, and high freak start on TIG welders. I'm going to be using a Miller Maxstar 150stl and also an Everlast PowerArc 140st. These are two machines that are comparable in size and high-end and low-end capabilities. There are definitely some differences, but these are the two I'm using today to use for demonstrations. Alright, hang with me today because about mid-video we're going to show some welding tips on stuff all the way from welding 4140 in 2 passes at max amperage on these two machines, and a few tips doing that, and then also we're going to test the low end by going down to some box cutter blades. So the Miller Maxstar 150stl, a couple of features on it. The argon flows through the DINS connector, so there's like this little spring-loaded sealing mechanism up in there that seals the argon, and it flows through the torch there, so you need only a 1 cable type torch. And then there's a plug-in for a foot pedal, so this machine is foot pedal ready. You have to buy it separate, but it's capable of using a remote amperage control. The settings are very simple. You got TIG remote, TIG panel, and stick, and then amperage, and that's about it. Strictly a DC machine, no aluminum. Same with the Everlast, very simple controls, amperage control, and a knob for a little switch for TIG and stick. And that's about it. Alright, now what is lift arc? Well, lift arc is just what it says. You basically touch and then you lift. And while you're touching, the machine senses that you've connected the current, and then you get a very low amperage, low voltage type current that doesn't melt anything until you pull it away. And that lessens the risk of contaminating the electrode or getting crap on the electrode or putting tungsten in the part. Now, scratch start, you got full current all the time, so you got to scratch it. You got to get your arc established and get your tungsten out of that melting metal pretty quickly. And I scratch it like a match like that, but it is still used in the field a lot. Now, what's high frequency? Well, high frequency start initiates a very high voltage, low amp current to jump a gap. Jumps an arc gap, and that lets you establish a welding arc, and then it usually turns itself off. Now, I've unhooked the ground here just to show you how wide an arc gap you can jump with high frequency start. You don't have to touch anything, and that's a good thing. I definitely prefer having a high freq start, but I know there's a lot of people interested, and a lot of people can't afford to get started with a full-blown TIG machine, so lift arc or scratch start methods are usually a lot cheaper. Now, I've seen some tricks in the field, some old-timers getting their arc started by flicking the rod and connecting the electrode in the piece. So here, I'll do it in slow motion here. I'm getting the electrode really close to the piece and getting the rod near there and then swiping it right by there and then swapping ends of the rod. Now, that technique is used by a lot of old-timers and new-timers alike, actually, for doing x-ray pipe. And the theory is if you contaminate the rod a little bit with electrode, you're swapping ends, so you can just throw that end away when you're done, and you lessen the likelihood of putting tungsten in the weld or putting crap on the tungsten. And it's just it's a technique. I've also seen plenty of x-ray welds done with scratch start without even doing that. But here it is in close-up. You got to get a really, fairly tight arc gap, less than the rod pretty much, and then you just swipe the rod by there. See, I didn't make connection there, so I've got to get it pretty close, and then you just swipe the rod by. So here we go. I'll try to do it in slow motion here. You can see what's happening. Boom, it gets the arc going, and now I've got a piece of copper backing what I'm welding here. That let me start on the copper. That's also a good trick for any lift arc or scratch start machine. Carry some copper around. You can mash some copper tubing flat, keep it in your pocket. You can tape it right next to where you have to start. Start on the copper and then go over to where you're going to weld, and you can all do the same thing where you got to come out. You can tape a piece of copper right next to where you're going to stop, and you can come up on the copper and maintain a little bit of gas shielding over the area where you've got to snap out. I'll show you how that works here in just a sec. So I'm pulling away a little bit and letting things solidify and cool a little bit, pulling onto the copper and then swiping out. Now just a little build-up bead. I'll show you again, lighten up and then going over. Having copper there gives you a couple of seconds time to adjust your helmet or whatever before you have to get over onto where you're going to weld. Now I'm using the Miller here. I'm going to listen closely. You hear when I touch there, the argon automatically kicks on. So that is one of the features of the Miller. It's got a built-in solenoid valve inside there that kicks the argon on when you touch. So we'll set the Miller all the way down to the bottom as far as it goes on the dial. I'm going to weld these box cutter blades. Now you notice I lit up on the copper, and when I came over to the blade it kind of melted the corners away. But you can see that was mainly my technique that caused that to happen. You can see the amperage is really low. It's almost not enough to weld this razor blade here. Now part of that is it's probably warped just a little bit and touching the copper, and it's drawing a lot of heat out. And when you do that, you need more amperage. It's just like turning the amperage down. But the point is, the point I'm trying to make here, I didn't know if these machines would be capable of welding really thin stuff since they're lift arc machines. And so I wanted to test both of them. I'm going to do the same thing with the Everlast. Turn it all the way down to 10. Again on the copper. Lighting up on the copper away from the weld, give myself a second. Here's a trick. I'm hanging a little bit of rod over the corner there first before I move the arc in, and then I'll let it roll under and join everything together and see it doesn't melt the corners away. That's mainly a technique thing, not anything to do with either machine. So once I get the tack done like that, I pulled back on the copper and then whipped out, kind of snipped my rod, and then you can see I'm continuing here. Now I would say there's maybe a 2 or 3 amp difference on the very bottom end of these machines, but both of them plenty capable of doing thin wall tubing and things like that. You can see how crooked I got on that joint too. I almost missed the joint. I didn't do that when I was 22 years old, but I'm not 22 anymore. Alright, we'll jack it up, the miller, all the way up to the high end, and I'm welding on some 1/2 inch thick scrap bar stock here. I want to do 2 passes on this. You can see I'm not coming out of the puddle very far with the rod. I don't want to contaminate the end of that rod. I'm just using the R70S2 3/32 rod, dipping and stepping and dipping and stepping, and it's hot enough to weld something this thick in 2 passes. I am hooked up on 230 volt and also with a 30 amp breaker so I can get the most out of this machine on the high end, but it's kind of surprising how hot it will go. And there I got to snap out. If I had the foot pedal hooked up, I would be able to taper off and then maintain coverage. Here's the Everlast at max power. Still, again, able to move that puddle along just fine on this 1/2 inch thick 4140 steel. You can see I'm just stepping the puddle ahead, pausing, and then dipping rod, trying to keep that tip of that rod shielded with the argon. I'm using a stubby gas lens kit on both of these torches, or actually on one of them. One of them's 17, but one of them's a 9 style, so I'm just using but I am using a gas lens on both torches. And so here's the Everlast second pass. You be the judge. Maybe I'm just not that picky, but they're very similar on the low end and the high end, other than the Miller being a little bit lower on the low end, I think. So there's the Miller welds, the thin box cutter 25 thousandths blade and then the 2-pass thick weld. And here's the Everlast box cutter blade and then the 2-pass thick weld that I did with it. Both units very comparable in size and weight, both very portable machines. The Maxstar has seemed to be go slightly lower on the low end, and has the ability to plug in a foot pedal. It's got a solenoid valve inside that initiates the argon automatically when you touch, and it's got a post flow. The basic Maxstar 150stl kit pretty much comes with a stick stinger and everything. You got to buy your own torch, or you can buy the Tig stick kit with it and get everything. And the Everlast comes with a 17 valve torch. You need a valve with it, stick, stinger, ground clamp, etc., and a carrying case. So summary is both of them are dual voltage and have good low end for thin metal, and both are capable of welding thicker metals with multi-passes. So that is it for today. Thanks for watching. Visit weldingtipsandtricks.com.